In this video, we're going to take a minute to look at our Wheels and Ladders lab, hopefully a relatively short video, because there's really only two questions. And the first question, which you might have noticed if you read through it at all, you can kind of do without actually doing any trick. And that is on purpose. It was not a kind of a get you situation. It's that you can look at it and tell what the answer is supposed to be. So you should be able to go through then now and prove it so you know where to look. Here's my Ferris wheel. This is the equation that's going to model this one. There's a couple of different ways that you can model it. Ferris wheels. This one actually is pretty good and makes the most sense almost compared to some of the other ones that I've seen. I say almost because the altitude and the height is the same. So if you were sitting on the Ferris wheel, the ground would rip your legs off, which would be a little bit of a bummer, but it's better than allegedly having a Ferris wheel that goes underground. So we're going to look at this Ferris wheel and answer a couple questions. And the first one says, during the first 40 seconds of the ride, assuming that it takes 40 seconds to go all the way around, right? Because it says the wheel takes one revolution every 40 seconds. At what time is an individual on the Ferris wheel exactly 125 feet above the ground? I'm going to take this over so we can mark this up a little bit. So you get on here, right? And it takes 40 seconds to go all the way around. We're going to assume safely that this is going at a constant speed, right? So 10 seconds gets you here. 20 seconds. 30 seconds. And then 40 seconds, you're back to where you started, right? So 40 or 0, depending on what part of the ride you're on. Well, 125 is my amplitude. So if we're looking at our circle, that is going to be our radius. So this is 125. This line starts 125 feet above the ground. So we're kind of assuming that this right here, if you want to think of it this way, is 0, 0. So as you go up, this is going to spin and you'll be 125 feet above the ground at 10 seconds. This is going to be 250, right? Because you'll be way up at the top. You'll have 2 radii. And then you'll be back at 125 seconds at 30 seconds. So your height is a 125 when t is either 10 or 30. So you might feel like, well, why should I bother solving it? So you know how to do it for when you can't just eyeball it. Let's see if we can go through and prove one side of this. I want to show that I'm 125 feet above the ground. I want to figure out when that happens. So I know my height, h of t, is going to be 125. And I want to know what t do I have to plug into my equation, which is 125 sine 0.157 t minus pi halves, and then I got another 1.25. We want to solve for t so that we can get down to 10 and 30. And if I remember correctly, I think you got to round it off. You know, you get like 29.99999, something like that. All right, so let's subtract 125 from both sides. So I get a 0 equal to 125 sine 0.157t minus pi halves. Divide off the 125. Well, 0 divided by anything is 0, so basically that just goes away. And I have 0 equal to sine 0.157t minus pi halves. So now I need to do inverse sine of both sides. That's a 1, not a 2. It looks like a 2. What angle has the sine of a 0? A 0 and a pi, right? Because you're right on the x-axis. And that's going to be equal to now 0.157t minus pi halves. So our coefficient of t, in this case that t is going to be our theta, is not a one and done. So after we get this split and this pi over 2 out of the way, and all we have left to do is to divide off that 1.157, that's when we're going to tack on the 2 pi k. So we're going to say 0 is equal to 0.157 t minus pi halves, or pi is equal to 0.157 t minus pi halves. And we'll add the half of pi to both sides. So over here we'll just get pi halves equal to 0.157 t. Scroll down. And then pi plus half a pi is 3.5 pi. I should say 1.5 pi, which is 3 halves. 0.157 t. Not one and done, so we're going to have to squeeze in the 2 pi k. Now let's divide through by the 0.157, or I prefer to think about it as multiplying by 1 over 0.157. It's just a little bit easier to see. This gives me pi over 0.314 plus, unfortunately, 2 pi k over a 0.157. That's t. That's my first general. This is going to be 3 pi over 0.134 plus 2 pi k over 0.157. And there's my other general. Now, we're talking about going through the Ferris wheel through the first 40 circles, 40 seconds. Do one circle, not 40 circles. You're doing one circle, so you haven't completed any part of the ride. So as soon as you get on, I'm going to scroll back up to here, and the clock starts ticking. During the first 40 seconds you're on there, you're only going to hit there twice. You wouldn't have completed a revolution yet, so it's going to, both my solutions are going to be in that k equals 0. If it went around again, then of course then that would be a 50, and then this guy would be a 70. But we're only looking at the first rotation. I'm going to scroll back down, and when k is 0, of course these go, because anything times 0 is 0, and we got to hope that this crazy number and this crazier number is 10 and 30. So let's get out the calculator and say pi divided by 0.314 is indeed 10. And the other one is, well, that times 3, 30. So you're going to do that a couple more times for different areas, on the circle, and for different rotations through. So like if it was the second loop around, when would that happen? You know what the answers are going to be. So if you don't get that t value, something went wrong. Now, the ladder question is a little strange. It's not quite as intuitive. You got 2 hallways. One's 3 feet wide, one's 4 feet wide. And for whatever reason, you're carrying ladders of various lengths. You want to know what is the longest ladder that I can bring through here and be able to turn. And I could just carry it straight through like that, assuming you're not tilting anything like that. You have this unfortunate equation right here that's set equal to 0. We're locked in the first quadrant, so it makes life a little bit easier. You're going to solve this for theta, so that at the end of the day when you solve this, it's going to be theta is equal to, and I will tell you it's not a terribly nice number. It's between 0 and 90, obviously, but it's not on the unit circle. My recommendation would be, and I can't do too much of it or else I just kind of give it away, is to add the 4 to the other side, the 4 cosecant cotan, and then change these to sines and cosines. So secant's 1 over cos. This is sine over cos. This is 1 over sine, cos over sine. So this becomes 3 sine over cos squared. And this is equal to, oh, I lost my 4. 4 cos over sine squared. And then it would cross multiply. So you got 3 sine cubed equal to 4 cosine cubed. You're going to want to do some creative division so that you get sine and cosine on the same side together, but your numbers on the other. Sine and cosine on top of each other is a nice thing, right? Because you can take that back out and put in either a tan or a cotan. You can take the cubic root of a trig function. So if you were to have something like a cosecant cubed, you can say, all right, take the cube root and just be left with cosecant because we're up in the first quadrant. It works. So do that. You're going to come down to theta being a kind of a crazy root of a weird trig function. It is it's around 45 degrees. Let's put it that way. It's pretty close to 45 degrees. After you get that magic number, you come back to here and you plug the magic number in for there, and it will tell you how long the ladder is. I'd give you a hint, but I can't remember off the top of my head. I'm tempted to say 9-ish, but I feel like that might be a lie. So I know for sure A is about 45-ish. So it's close to that. Hopefully this will help you with your wheels and ladders, and if you have any questions, let me know.